Section 3.5 Graphs of Rational Functions and Their Applications. Vertical and horizontal asymptotes. Recall, from 2.2, we looked at finding the domain of a rational function f of x, which was p of x over q of x, one polynomial divided by another. The domain came from finding the zeros of the denominator. The line y equals b is a horizontal asymptote of the graph of a function f, provided that as x gets really large, the function value approaches that number. Or if x gets really large in the negative direction, if the function value approaches there, that's a horizontal asymptote. The line x equals a is a vertical asymptote of a function f, provided that the value of the function goes towards infinity as you get closer and closer to the x value in question. A function can have more than one vertical asymptote, but only one horizontal asymptote. If a number a is a zero of the denominator of a function, and p of x and q of x do not have common factors, then x equals a is a vertical asymptote. For horizontal asymptotes, to determine them, you must look at the degree of the numerator and the degree of the denominator. If the degree of the numerator is less than the degree of the denominator, then the x-axis is the horizontal asymptote. That is, as you go towards infinity, in either direction, the function value tends towards 0. If the degree of the numerator is equal to the degree of the denominator, then the horizontal asymptote is the quotient of the leading coefficients of the numerator and denominator. If the degree of the numerator is bigger than the degree of the denominator, then the graph of the function has no horizontal asymptote. Let's find the vertical and horizontal asymptotes of the following functions. Part 1. To find the vertical asymptotes, we factor the numerator and the denominator. So 3x over x squared minus 5x minus 6. The numerator is already factored, and the denominator factors into x minus 6, x plus 1. Nothing cancels, so there's going to be a vertical asymptote wherever the denominator is 0. So the vertical asymptotes are the lines x equals 6 and x equals negative 1. Those are the numbers that make the denominator 0. To find the horizontal asymptotes, we look at the degree of the numerator and the degree of the denominator. The degree of the numerator is 1 because the highest power of the numerator is 1. The degree of the denominator is 2 because the highest power of x in the denominator is 2. So the degree of the numerator is less than the degree of the denominator. In this case, the horizontal asymptote is the line y equals 0. Part 2. To find the vertical asymptotes, we factor the numerator and the denominator. The numerator is x squared plus 10x plus 25, and the denominator is x squared minus 64. The numerator factors into x plus 5 squared. The denominator factors into x minus 8, x plus 8. It's the difference of squares. We factor the numerator and the denominator to see if they share any factors. If so, we cancel them first. After we cancel them, anywhere the denominator is 0 is going to be an asymptote. So in this case, the line x equals 8, that comes from here, and the line x equals negative 8, that comes from here. Those are the vertical asymptotes. For the horizontal asymptotes, we again look at the degree of the numerator and the degree of the denominator. In this case, the degree of the numerator is 2, and the degree of the denominator is also 2. Since these are equal, the horizontal asymptote is the line y equals first term of the numerator divided by the first term of the denominator, which is 1. So it is the line y equals 1. Again, asymptotes are lines, so we're giving equations of lines. Part 3, we look at the vertical asymptotes. Here we factor the numerator and the denominator. In this case, both are factored. So now we just need to check where the denominator is 0. When is x squared plus 2 equals 0? If I subtract 2 from both sides, I see x squared equals negative 2. No real answer will give that. So there's no vertical asymptotes. What about horizontal? Again, I look at the degree of the numerator and the degree of the denominator. What is the highest power of x? Here, the highest power of x is 0, because there is no power of x. What's the highest power of x on the denominator? It's 2. In this case, the degree of the numerator is less than the degree of the denominator. So the horizontal asymptote is the line y equals 0.